Hello, good afternoon, good morning, good evening, or whenever you happen to be watching this video. Welcome to part 1 of lecture 1 of ENGR 2301 Engineering Statics. So in this video, I want to go through what statics is, the prerequisites for it, where we are, where we've been, and where we are going. So let's talk about statics. What is it? What is statics? So all of you signed up for this class, and we've all looked at what, and you hopefully have some idea what statics is. But let's go and really dig into what statics as a study really entails. So I could ask many people what statics is, but and we could define it many different ways. But perhaps how I would define it is, I would say statics perhaps is the study. The study of forces and masses and how they distribute through systems that are not accelerating, and how they distribute through stationary systems. I could say to travel through stationary systems. So, for example, statics. As we'll see, or as you can see in the course syllabus, we cover many different things in statics. We're going to look at things like, how forces distribute through bodies. We're going to look at things like where the center of mass of objects is. We're going to look at centroids. We're going to look at trusses. We're going to look at moments of inertia. We're going to look at many different topics, but really all of these boil down to the study of forces and masses and how those forces and masses travel or distributed through stationary systems. So we're not looking at things that are accelerating, rather we're looking at things that are stationary, or at least are moving at a constant velocity if you want to be very physics technical. So what comes before statics and what comes after statics? Let's look at this from the point of view of courses, or a line of courses. I really do like statics. It's one of my favorite courses to teach because it really is truly a foundational course in civil and mechanical engineering. So let us consider statics for a moment. What comes before it, and what follows after it? So we have this course that we call statics. And what feeds into this? Well, the prerequisites for this course are Physics 1 and Calculus 2. So that's definitely feeding into it. In our standard Physics 1, if you're not familiar with our system, if you're watching from out of the country or something, Physics 1 is typically your Newtonian physics. Physics 2 is usually your electromagnetism, that sort of thing. And so we won't need electromagnetism in this course, although that will be good to know, especially very useful if you're an electrical engineering student or something like that. But Physics 1, Newtonian mechanics, is the most useful and most apropos for a statics course. And of course, we're going to need Calculus 2. We need to make sure we can do some basic differentiation and integration before we arrive at statics, and these are just your basics. And really, many of the things that we're going to see in statics class you may have seen before. So for example, centroids, you may have seen that before in physics class. Things like basic static equilibrium, you've probably seen before in physics class, either university or even high school physics, to a limited degree, but we're going to take it to a much higher level than what you've seen in previous courses. So, what comes after this? Well, immediately following statics is a course called dynamics. These two courses are very similar. The main difference between these, both of these are going to be concerned with bodies that do not deform, that do not bend, flex, twist, or change shape in any way, but the main difference between statics and dynamics is that both of these are dealing with rigid bodies. That's a similarity between them, but the main difference between these is that statics deals with things that are stationary, and dynamics, of course, deals with things that are moving, static versus dynamic systems. And often these are grouped together, and even sometimes published in a single book, in a single textbook. I would call, sometimes these are combined, referred to as your engineering mechanics texts, or your engineering mechanics courses. So engineering mechanics, you have both statics and dynamics. Engineering mechanics is made of two courses, both, or at least how we traditionally grouped them. Engineering mechanics is traditionally grouped in both statics and dynamics. So, what happens after this? Well, if we look at this from the point of view of, say, civil engineering, now I'll look at this mainly from the point of view of civil engineering, but we could draw a similar path for mechanical. After you look at these, or after you take these, I should say, there are a whole line of courses that feed into this. And I'm just going to draw a very simple path. So, for example, for civil engineering, if you're going more of a structural point of view, or if you're going down more of a structural track, after statics, you would take a course called Mechanics of Materials, and here you start looking at stress and strain and how they distribute through bodies. Then after that, you might take a course called Structural Analysis, and here you deal with frameworks and things like virtual work and all these kind of good things. Really looking at shear moment diagrams applied to entire frames, basically taking many of the things we looked at in statics, but then taking them to the nth degree. Also, often combining this with some form of computer analysis. Usually in structural analysis, we start introducing students to some basic computer modeling, things like that. And then after this, you can have things like steel design, concrete design, and a whole host of other courses. And there are other courses that come after this, that branch off of this, I should say. For example, after mechanics of materials, you'll have things like, you can have things like soil mechanics. You can have your materials courses, your civil engineering materials courses, etc. And you can also have other offshoots from statics, like, for example, fluid mechanics. It comes off of statics and dynamics. Usually. Many of the things we're going to look at in terms of centroids and distribution of forces are very applicable to the study of fluids. And there are many applications there are many applications to this as well in mechanical engineering. I drew this out for civil engineering. This is more the civil side of things. But we could draw something similar from mechanical engineering. So, for example, fluid mechanics and mechanics of materials are both courses that are taken by both civil engineers and mechanical engineers. Now, depending on your university, here at our university, we actually allow students for civil and mechanical. They can take either one. There's a civil mechanics of materials and a mechanical engineering mechanics of materials. But students can take either one. They're close enough that you can satisfy your prerequisites by taking either one. But some universities that are larger a bit, they'll have very specific ones that they really want students to take. If they're civil, they really want them to take the civil one. Mechanical, they really want them to take the mechanical one, so on and so forth. But then after this, there are a whole series of other courses that feed from these. So after fluid mechanics, on the mechanical side, so for mechanical engineering, after statics and dynamics, you'll have your fluid mechanics again, usually taught with a bit more of a focus on mechanical engineering, again depending on the university. But then after this, we'll usually join with thermodynamics. You'll have things like heat transfer, a very essential course for any mechanical engineer, especially if you want to go into things like power plant design, that kind of thing. And then, let's see, after mechanics of materials and dynamics, you put these together, you can get things like dynamics of machinery. If you want to just study things like powertrains and drive systems and all that fun stuff that civil engineers don't have to worry about. Dynamics of machinery. And this is by no means a comprehensive list. There are a whole series of courses that follow after statics and dynamics, and that we could, if I could sit down with a university, course catalog and draw out something 10 times as large as this. Statics and dynamics really truly are foundational courses to the study of civil and mechanical engineering. Typically, they're taken. Traditionally, at least, they're taken in the sophomore year of a civil or mechanical engineering track, and they're absolutely foundational to teach you some of the most basic concepts you will need for your further study as civil or mechanical engineering students. So again, it's the study of forces and masses and how they travel through stationary systems, and this is sort of where they fit into the broader course outline, or the broader or the broader array of courses in an engineering education. So what kinds of things do we look at in statics? What are some applications of statics? Statics, let's look at where we apply it. So consider statics. Where might we apply this? So, for example, let's say I were to look at, I can think of any number of things. Now we can look at the things we're going to directly learn, but basically, maybe I want to speak in fairly broad strokes here. So, anything involving building design, anything involving buildings and structures. Anything involving buildings and structures. So if you have any kind of structure, any kind of building, any kind of tower, anything that is standing above the surface of the earth, that is going to be designed in accordance with the principles of statics. What else? How about any kind of road system? So if you're doing highway design, if you're doing pavement design, if you're doing any of that, you're going to look at how the forces from vehicles and things like that distribute through the road deck, through the upper layers, through the sub layers, all that kind of stuff. All of that comes down to statics. Any water distribution system, with a fair amount of dynamics as well. And many of these will involve both statics and dynamics. For example, structures. Even though you think of structures not moving, especially when you get to more flexible structures like bridges and tall buildings, those are absolutely designed with dynamic forces as well. But any kind of water distribution system, you think of that as a fairly dynamic system, but that is actually designed with a lot of the principles of statics in mind. So these are some civil ones. Obviously, any kind of foundations and soils. Again, statics is the study of how forces and masses behave in relation to each other. So if you have for example, if you're designing a retaining wall, so you have a surface like this, and you're designing a retaining wall like this, and you have like a large amount of earth behind here, and you want to design a retaining wall to hold this back, you absolutely need to have a strong appreciation and understanding of how forces and masses and stresses and things distribute through materials. If you don't know how to do that, you cannot design something like this. That is absolutely essential to the design of any kind of earthwork system, any kind of foundation, anything resting on or in the earth. So these are some kind of civil things. What about mechanical? We have both civil and mechanical engineering students in this class. So I do try to give examples when I can for both civil and mechanical. So these are all really civil related things. What about mechanical? So, mechanical. How would I use this? Why is this important? Well, mechanical, for example, consider this. What if I want to look at the torque in a system? Torques, say in a drive shaft or in a series of gears, pulleys, that sort of thing. Torques, gear stresses. Internal forces and engines, all this kind of stuff. How about pressures? Pressures in boilers. Pressures in fluid distribution systems. And fluid conveyance systems. All of that applies the principles of statics. And if nothing else, even if you say that's not important, I am a mechanical engineer, I don't want to deal with anything that even has a whiff of civil, at the end of the day, you'll still need, even if you have something stationary, if you ever have something stationary, even just things to hold up pieces of equipment, supporting systems, all that kind of stuff, supporting equipment for machinery, all of that good equipment, supporting equipment, etc. Basically, everything that civil and mechanical engineers do, with few exceptions, fundamentally will come back to the laws of statics. It is absolutely essential to any complete education in the fields of civil or mechanical engineering. So, Especially as we go through the semester, some of the stuff we'll look at will seem fairly theoretical. And I remember when I was taking statics that I remember, I knew I wanted to do structures, and I remember looking at some of these things, and I didn't quite have the big picture yet. And I didn't have or I should say, I didn't quite have an appreciation for the big picture yet. And I remember looking at some things in statics or dynamics class, and for example, in dynamics class, I remember seeing things like, for example, in dynamics class, I remember when I was an undergrad, I would have things like, oh, here's a problem with a ball on a spring with a, with a damper here. Maybe there'd be something like this with a ball on a spring and a mass with a damper. And I remember as an undergrad, I would sometimes get very frustrated because I had no idea what this had to do with anything. This was very theoretical. I saw this and said, now you probably don't know what a damper is yet, unless you really read your physics text and remember very clearly. But don't worry about that. This is just an example. So you'd have some K and some coefficient of damping, etc. And I remember looking at this, and again, this is dynamics class, not civil, but I remember this example from dynamics class, and I remember looking at some of these systems, and I was really frustrated because I thought, okay, what does this have to do with anything? I want to design buildings and towers and structures. What in the world does this have to do with anything? Why am I learning this crap? Why does this matter? And especially as we go through the course, sometimes there will be things that seem very theoretical and don't have a strong connection to what we want to look at. But as you get the bigger picture, as you start to develop more in your knowledge, you start developing more skills as you get to your more advanced classes and get some career experience, etc., you will see that the things you learn in this class are absolutely foundational. Yes, in your later courses, they may be more practical and a bit more applied than some of the things we'll learn in this class. But this class gives you the absolute theoretical, the firm theoretical foundation that you will need for your later coursework. So, for example, we'll have things like, we might have a problem in this class. A classic statics problem might be something like this. I say, oh, here is a pin on a surface, and here's a vertical surface. Here's another pin. And maybe there's one rod connecting this to here. And there's another rod connecting this to here. This is a classic kind of statics problem. And then maybe there's an applied force P down here that I'd give you some magnitude of, and we'd have the dimensions of this and the angles and all that kind of all the stuff we would need. And I would ask us to find the internal forces in this member and the internal forces in this member, and the reactions here and the reactions here. That is a classic statics problem. And looking at this kind of simple system, now this looks like something you'd make with an erector set back as a child or something like that, but now, as a, you might be looking at this as a mechanical engineering student or something and saying, oh, what does this have to do with anything? I want to design engines, or I want to design turbines. What does this matter? Why do these, rods and forces and everything else? But if you can understand this, you will need this kind of knowledge to then apply to things like turbine blade design and things like a rotating shaft design and all the kinds of things that you will learn in your later coursework. But at the level you are at now, right after you just finished your calculus and you just finished your basic physics, it's one of those things you can't jump directly to the perhaps more practical stuff. You got to get your basics, and you'll work your way up the ladder, just like anything else. Just like you've seen before in life, as you work your way up from, we could talk about climbing the ladder all the way from elementary school math. You climb a ladder to here, and this is another rung in the ladder. So hopefully that is a brief introduction to what statics is, what are some of the applications and coursework involved in statics, and we'll look more at this and some other materials in part 2 of this lecture. All right, that'll do it for now, and as always, thank you.